Hello, it's Keith here, and this is lesson 3 of the platform-specific series of my TI-99 assembly programming tutorials. Today we're going to be looking at sounds, and we're going to look at how to make sounds with the TI-99. Now the TI-99 uses the TMS9919 sound chip, which is almost the same as the one in the Master System, and there was also some support for it in the Genesis, which was a bit of a surprise for me. I programmed this thing before with the Master System and the Game Gear, and I thought I wasn't going to have to deal with this sound chip again, and it popped up. It uses a slightly different name, but it is basically the same thing. So we're going to have a look at it, we're going to discuss it, and I've actually ported the little sound drive, which I call ChibiSound, to this system so that we can make a simple sound just with a single byte parameter. Okay, so how does sound work on the TI-99? Well, it's pretty straightforward in a way, and it's pretty tricky in another way. Basically, there's just one port, a single byte of data we send with port 8400. So we just write a byte to this port, and that will define what happens with the sound chip. Now, the format of that byte is a little bit tricky potentially. Basically, the top bit, bit 7, is known as the latch bit. This is either a 1 or a 0. A 1 for the first command, a 0 if there's a second parameter that's added to that first one. And that's the case with the tone. So generally speaking, this will be 1. Then we've got 2 bits that are the channel. There's 4 channels, 0 to 3. 0 to 2 are tone channels, and 3 is the noise channel. Now, bit 4 is the type. With this will be a 0 if we're setting the pitch or the noise settings, or a 1 if we're setting the volume. And the remaining 4 bits will either be the low part of the tone, or the volume, or the settings for the noise channel. So it's a little bit tricky. This is kind of the template, if you will. Now, the exception to this is when the latch bit is 0 for the pitch. That gives a remaining 6 bits that make up the HL pair that define the tone. So this is basically the kind of settings we'll see, and ChibiSound uses a variety of these. Now let's go over to the code and let's hear ChibiSound in action. So what does ChibiSound do? Well, it takes just a single byte in R0 here, and this will define the tone that is made, and it's designed for making simple sound effects in games. Here you go, a simple Space Invaders type of game that doesn't need anything particularly special, but it's designed to be multi-platform. So here you can hear a noisy sound here, and now it's a bit louder. There are 2 possible volumes, high and low. There's noise on, noise off, and then there's a total of 64 different pitches we can have, and a byte of 0 will turn the sound off. So you can hear a variety of different sound effects here based on this single byte. And that's really what ChibiSound does. It's pretty simple, but it's allowed me to port my games and have some sound on all these systems. Okay, so we're going to go over the code that drives ChibiSound, and then through doing that we'll see some of the settings that are available and how it works with the sound chip. Now, as I say, all of the settings are done with port 8400 in hexadecimal. So we're loading that into R1 here, and that means we can transfer data to the sound chip with *R1 here, and that's all we'll need to do. Okay. Now, as part of defining our sounds, we're going to use 2 possible channels. We're going to use channel 3, because that's the noise channel for those distorted effects, and we're going to use channel 2 for our tones. Now, why are we using channel 2 and not channel 1 or 0? Well, channel 2 is special when it comes to noise. Our noise rate can be 0, 1 or 2, or it can be 3, in which case tone 2 is defining the noise frequency, and that's what we're doing to get the noise effect. So we couldn't use channel 0 or 1 to do that. We can only use channel 2, and that's why we're using channel 2 for our tone as well here. Now, at the start here, we're just silencing both of them, and we do that by setting the volume to the maximum of 15, which it's kind of backwards. 0 is loudest and 15 is quietest. So that's silencing these channels here. Now, you can see here that the type bit is set to 1, which is a volume definition. The latch bit is set to 1. It's always 1 in a volume setting, and it's always 1 in the first byte of a setting anyway. And then the channel here, this is channel 3, so that's the noise channel, and this is 1, 0, so that's channel 2, the tone channel we're using. Okay, so that's silenced our sound. Then we're masking out the top byte, which is the only one ChibiSound's using. If it's 0, we're done because we're silencing the sound here. After that, we're going to set our tone. So what we're doing here is we're taking our bits here, and then we are flipping the bits, and then we're taking effectively the bit 6 here, which is the only volume bit in the ChibiSound definition, and then we're shifting it to the left to this position here. We're then ORing in this mask here, which will set tone channel, channel 2. We're setting the volume here, and we're going to set the other bits to 1 here, and then we're going to transfer that to the sound chip here, and that will effectively set the volume for tone channel 2. Now at the same time we're making a backup of this because we might want to use this defined volume for the noise channel, which of course is a different channel. What we're doing next is we're testing the top bit of the parameter, and this is the noise bit, and if this is 1, we're jumping down to this section here where we're going to define the noise. But if we're making a tone, what we do next is we are defining the pitch. Now we've only got 6 pitch bits within the ChibiSound definition, that's these ones here. So we're going to always set the low bits to 1 here. We're doing that just here. So we're sending the first byte, the latch bit is 1, the channel is channel 2, the type bit is 0 here, and we're sending that, defining those low bits. Next we want to set the high bits. Now this time the latch bit is 0, and this is the only time, if you remember, that the latch bit is going to be 0. It's only when we're setting the high bits here that the latch bit would be 0. We're getting these, we're masking them from our past parameter here. We're just doing that here, and we're then transferring that to the sound chip, and that sets the high bits of the tone, because that's the second parameter after the first one, which had that latch bit as 1. And then once we've done that, we're then just turning off the noise channel here, and then we are just done. So we just return. If alternatively we're making a noise, then what we're doing here is we're setting the low tone bits here as before, this time again of channel 2, because channel 2 defines the frequency of the noise. We then set the high bits here in the same way as before, again to channel 2. What we then do next is we mute the volume of channel 2, because while we need its frequency, we don't want it to actually make a sound. We then enable the noise mode. We do that here by setting the top 3 bits to 1, the latch bit 1, channel 3, and then we set these 3 bits here to 1. This specifies to use white noise, and the 1 1 at the bottom 2 bits here defined to use channel 2 for the frequency, and that's why we've set the frequency here of channel 2. Finally, what we're doing here is we are using the previously calculated volume that we calculated up here, and we're using that for the noise channel here, and that will make the sound of the noise here, and that's how we're doing it. So that's how we can control the sound chip. As I say, basically it's a little bit tricky, but effectively we can set our pitch with a pair of consecutive writes to a channel. We define the channel in the first one, and then we define the 10 bits of pitch here. And then with the volume, we have to set the top bit to 1, we have to set bit 4 to 1, the bits 5 and 6 here again are the channel, and the volume 15 is the lowest and 0 is the highest, a bit backwards. And the special case is the noise channel, channel 3 here, and we've got those options for white noise and 3 possible rates, or using tone channel 2. That's all there is to it anyway. You can use my ChibiSound driver if you're just looking to make simple beeps. It's what I used in all of my games like YQuest and Grime Z80, so hopefully it's good to get started. But if you need something a bit more advanced, then you can use hopefully as an example of how to make sounds. I also did an example on the Master System and Game Gear of playing a digital sample, and I'm sure that would work just fine, because as I say, it's effectively the same sound chip. So if you wanted to convert that, I'm sure you could do so, but it's not something I'm planning to look at here. Anyway, I hope you found this interesting. If you want to, you can go to my website and download today's example and give it a go. If you find it useful, then brilliant. If you've liked this video, please like and subscribe. If you like the videos, YouTube's more likely to recommend them, and if you subscribe, I'm more likely to keep making them. So please think about doing that. But whatever you do, I hope you have fun making sounds on the TI-99. Thanks for watching today, and goodbye.